Hi there, I'm Graham Lewis, and in this video we're going to solve these two algebra equations involving fractions. You can see that the first one is two fractions and the second one has got the unknown on both sides, and we'll need brackets as well. And I'll show you some different ways of doing these. Let's get going. Okay, if we start off with this little squirrel here, we've got x over 2 plus 2x over 3 equals minus 4. And I think a good approach, and one of my grade 8s are really enjoying, is the common denominator approach. So let's think about this. Now, you can think about negative 4 as a fraction. It's negative 4 over 1. So what's the common denominator of 2, 3, and 1? And we can quickly come up with 6. So we're going to write everything with a common denominator of 6. And there's a reason for that, because then we can multiply both sides by 6 and it'll get rid of all of the divide by 6, which is rather quite beautiful. So this is one way to solve these equations. So let's take that fraction x over 2, and remember, to write it as over 6, I need to multiply top and bottom by 3. And x times 3 is a 3x. So you end up with 3x over 6. Now let's take the 2x over 3, and to write that as something over 6, I need to multiply top and bottom by 2 of the fraction. And 2x times 2 is 4x. So 2x over 3 is equivalent to 4x over 6. Because effectively you've multiplied by 1. 2 divided by 2 is 1. It's a special number. Multiplying by 1 and adding 0, by the way, are two great tricks in mathematics that mathematicians use at very advanced levels, including university maths as well. So we've got 3x over 6 plus 4x over 6 equals, and then negative 4 over 1, we can write over 6 as well. And we've multiplied top and bottom by 6, so 6 times 4 is 24. And there we go, we've got everything multiplied, everything with a common denominator of 6. Step 2 in this algorithmic approach is to multiply everything by 6. You can do that in your heads. If you multiply the left-hand side by 6, you get rid of the divide by 6, get rid of the divide by 6, multiply the right-hand side by 6, get rid of the divide by 6. And you end up with 3x add 4x equals negative 24. Always simplify. So you've got a 7x equals negative 24, and then you can divide both sides by 7, and Bob's your uncle. Maybe Bob's not your uncle. I don't have an Uncle Bob, but I like the expression. So 7 divided by 7 cancel, leaving you with a 1x, and 7's into 24 go 3 times, that's 21, remainder 3, so we've got the answer of minus 3 3/7. So that's one way of solving this. I hope you like that way. My grade 8s are really enjoying the common denominator approach, and the only sneaky thing is to remember that a number like negative 4 can always be written as a fraction, negative 4 over 1. Okay, try that one on your own. Pause the video, try it, and then compare. There's no way to learn mathematics better than actually doing it yourself. Okay, so now let's have a go at this second one. 2x plus 7 over 2 equals x over 5. Now, I'm going to show you two approaches to do this. Let's do the common denominator approach first, and I'll call that method 1. And I'm going to let you choose which method you prefer. So in method 1, I'm going to call that x minus 5 over 1. So, because just like you've got a number. Now, some of you might find this quite hard, so therefore you might prefer method 2. We'll see. So, let's make a common denominator of 2. So I've got 2x plus 7 over 2 equals, now to multiply this fraction x minus 5, this is the tricky bit with this method. To make that a common denominator of 2, you need to multiply top and bottom by 2. But you need to remember to multiply everything on the top by 2. So you can use a bracket, 2 brackets x minus 5 to show that, which is my preferred way, or you can actually write 2x minus 10. Which is what you would get if you multiplied out that bracket anyway. I don't mind which method you do. I tend to like using the brackets because I go slower, showing more of my working. So 2 times the whole of the numerator. Once you've got the common denominator, multiply through by the common denominator and it will cancel. And you're left with 2x plus 7. And there's nothing wrong with doing some work here on your own. Multiply the 2 by the x, the minus 5 by the 2, and you get 2x minus 10. Now this is a really sneaky question, this one, because when you're solving an equation like this, and I'm going to do another question as well that's quite complicated to this. This one, you want to get all the x's on one side. So you actually want to subtract 2x from both sides. But look what happens when you do that. Because when you subtract 2x from both sides, something in this question makes it very peculiar and very strange. Probably could be a question in a Harry Potter novel, because the 2x minus 2x cancels, and you're left with 7 equals minus 10. And you might think at this stage, what have I done wrong? And the answer is nothing. You've done everything perfectly correctly. What this means, because obviously 7 does not equal minus 10, and you should put a not equals there, not equals there, not equals there, not equals there, and actually a not equals there. What you're actually saying is there's no value for x that works in this ever. Okay? So this is a really cool question. So it's a really, really lovely question, because it gets you thinking that not all equations you can get an answer. So this is an example of one you can't get an answer. Okay, so I hope you enjoyed that. Now obviously when you get down to x's on both sides, usually you will get an answer, especially at high school mathematics. But this is a nice example to show that sometimes there are impossible questions where there's no possible answers. Hope you enjoyed this video, and good luck with your algebra, and take care everyone.